welcome back. Today we're going to look at how to solve some definite integrals using u substitution. So when you solve a definite integral with a u sub, we're also going to have to make sure that we are changing our limits of integration. So here we go. Let's get started with number 53. I'm going to start right away by saying what my u sub is going to be. And in this particular problem, my u sub is going to be u is equal to y plus 1. So du is going to be equal to dy, a fairly easy u sub. And keep in mind, if y is equal to 0, which is that lower limit of integration, then u is going to be equal to 0 plus 1, so u is equal to 1. If y is equal to 3, then u is going to be equal to 3 plus 1, so u is 4. And what I'm doing here is I'm plugging in the y value into the u equals y plus 1. Alright, let's work it out. So this becomes the integral from 1 to 4 of the square root of u du. And so I get this is the integral from 1 to 4 of u to the 1/2 du. So this becomes 2/3 u to the 3/2 from 1 to 4. So this is 2/3 times 4 to the 3/2 minus 1 to the 3/2. So this is 2/3 times 8 minus 1, which is 2/3 times 7, which is 14 over 3. Alright, moving on to the next problem. Here we have the integral from 0 to 1 of r times the square root of 1 minus r squared dr. I do recommend that we're going to rewrite this in just a second, but we're going to do our u sub first. So we're going to have u is equal to 1 minus r squared. So du is going to be negative 2r dr. I don't want the negative 2 because I can rewrite this as the integral from 0 to 1 of the square root of 1 minus r squared times r dr. So I'm going to multiply both sides by negative 1/2. And now I can use my u sub, but before I do that, I'm going to figure out what my new limits are. So if r equals 0, then u is equal to 1 minus 0 squared, so u is equal to 1. If r is equal to 1, then u is equal to 1 minus 1 squared, so u is equal to 0. So I'm going to rewrite my integral using my u sub, and this becomes the integral from 1 to 0 of the square root of u times a negative 1/2 du. So this is negative 1/2 the integral from 1 to 0 u to the 1/2 du. And what I'm actually going to do here is I'm going to switch my limits of integration by multiplying by a negative. So I get 1/2 from 0 to 1 u to the 1/2 du. So I integrate and I get 1/2 times 2/3 u to the 3/2 from 0 to 1. So this is going to be 1/3 times 1 to the 3/2 minus 0 to the 3/2. So this is 1/3 times 1, which is 1/3. Alright, so we have the integral from negative pi over 4 to 0 of tangent of x secant squared of x. So I'm going to let u equal tangent of x. So du is going to be secant squared x dx. So if x is equal to negative pi over 4, we get u is equal to tangent of negative pi over 4. So then u is going to be equal to negative 1. You can figure that out by looking at the unit circle. That's right here when negative pi over 4 gives you these x and y values. And then we have x is equal to 0. So then u is equal to tangent of 0. So u is equal to 0. Because that would be this angle right here on the x-axis. So now I'm going to rewrite my integral. And we get this is the integral from negative 1 to 0 of u du. So when I integrate this, I get 1/2 u squared from -1 to 0. If you wanted, you could have multiplied it by a -1 to flip the limits of integration. And then here you're going to get 1/2 times 0 squared minus a -1 squared. So I get 1/2 times -1, which is -1/2. All right, moving on to number 56. We're almost there, only a couple more. So here I'm going to let u equal basically what's in my denominator, which is 4 plus r squared. So du is going to be equal to 2r dr. So I have a 5r dr in my numerator, but keep in mind that that's not really that helpful. So I'm just going to go ahead and get rid of this 2, and I'm going to write this as 1/2 du equals r dr. Now I wish there was a 5, so I want to multiply both sides by 5, and I'm going to get 5/2 du equals 5r dr. And then I have to change my my limits. So if r is equal to -1, then u is equal to 4 plus -1 squared. So u is equal to 4 plus 1, so u is equal to 5. If r is equal to 1, you get u is equal to 4 plus 1 squared, so u is also equal to 5. So I'm going to go ahead and I'm going to rewrite the integral. And this is going to become the integral from 5 to 5 of 1 over u squared times 5/2 du. Notice right here that our limits are exactly the same. So this whole thing equals 0. You don't have to bother integrating it or any of that because the limits are exactly the same. All right, now let's look at 57. So for 57, I'm going to let u equal 1 plus theta to the 3/2. And keep in mind, theta is just a variable, like x or y. So I take the derivative and I get du is equal to 3/2 theta to the 1/2. I don't have a 3/2, so I'm going to multiply both sides by 2/3. So I'm going to get theta to the 1/2. I do wish I had a 10 there, though. So I'm going to multiply both sides by 10. I'm going to get 20 over 3 du equals 10 theta to the 1/2. Forgot my d thetas. So if theta is equal to 0, u is equal to 1 plus 0 to the 3/2, so u is equal to 1. If theta is equal to 1, you get u is equal to 1 plus 1 to the 3/2, so u is equal to 1 plus 1, so u is equal to 2. And now we're going to rewrite it with our u sub. So this becomes the integral from 1 to 2. The 10 theta d theta is going to be replaced by the 2/3, 20/3 du. So you get 1 over u squared times 20 over 3 du. So this becomes the integral from 1 to 2, u to the -2 times 20 over 3 du. This becomes 20 over 3, the integral from 1 to 2, u to the -2 du. So when I integrate this, I'm going to do this on the side over here. I'm going to get 20 over 3 negative u to the -1 from 1 to 2. So this is 20 over 3, put a negative on the outside, 1 over u from 1 to 2. So it's negative 20 over 3 times 1/2 minus 1 over 1, negative 20 over 3 times negative 1/2. And so you get your final answer is negative 10 over 3. All right, now for number 58. So number 58, we have 4 plus 3 sine of x in the square root and denominator. I have a cosine x in the numerator, so I know right away I'm going to be able to do a u sub. So I know u is going to be equal to 4 plus 3 sine of x. And du, because I take the derivative of this, I'm going to get 3 cosine of x dx. I don't want the 3, so I multiply both sides by 1/3 cosine of x dx. And then we have to do our limit change. So if u is equal, or I'm sorry, not if u, if x is equal to negative pi, we get dx. Just kidding, don't take a derivative. Don't take a derivative. Then u is equal to 4 plus 3 sine of pi. So you get u is equal to 4. If x is equal to pi, we get u is equal to 4 plus 3 sine of pi. Sorry, this should be negative pi. And u is going to be equal to 4 as well. So we're going to rewrite it with the u sub, but something funny is going to happen. This becomes the integral from 4 to 4 of 1 over the square root of u times 1/3 du. Notice that these are the same, so it equals 0. All right, very last problem. This time we're going to find the integral from 0 to 1 of the square root of t to the 5th plus 2t times 5t to the 4th plus 2 dt. So let's start with our u sub. We're going to get u is equal to t to the 5th plus 2t. Notice that when I take the derivative, I'm going to get what's right there. It's very nice. That's usually how you know you're doing something right. So when t equals 0, you get that u is equal to 0 to the 5th plus 2 times 0, which is just 0. So when t is equal to 1, we get u is equal to plus 2t. So u is equal to 1 to the 5th plus 2 times 1, which is 1 plus 2, which is 3. So let's rewrite our integral. We're going to get this becomes the integral from 0 to 3 of the square root of u times du. So this becomes the integral from 0 to 3. I always like to write my square roots like this. Makes it a little easier for me to integrate. This becomes 2/3 u to the 3/2 from 0 to 3. So I get 2/3 times 3 to the 3/2 minus 0 to the 3/2. So this becomes 2/3. And I'm going to rewrite, I'm actually going to work the 3 to the 3/2 out. This becomes the square root of 3 to the 3rd power. So this is 2/3 times the square root of 27, which is 2/3 times 3 square root of 3, which becomes 2 square root of 3.